let's get to these notes. We have complex conjugate zero theorem. These theorems all have fancy names and they're stated kind of crazy, but if you can apply them, that's all that really matters. So if we read through this, don't get too crazy. We'll actually do a problem or two, and you'll see it's not too bad. All right? So it says, suppose that f of x is a polynomial with real coefficients. All right? Big deal. We've done polynomials. We've done them in the previous problems. X cubed plus x squared plus x plus some number. All right? And real coefficients mean, okay, big deal. They have a 3 in front of them. They have a 2 in front of them. So what? All right? This says if a and b are real numbers, with b not equal to 0, and a plus bi is a 0, then its complex conjugate, a minus bi, is also a 0. All right? First off, why do you think they say b cannot be 0? What happens here in this complex number if b is 0? What happens if b is 0?
B is 0.
Well, what's anything times 0?
0.
Yeah, this would go away if b is 0. So then it wouldn't be a complex number anymore. It'd just be a regular number. A is a real number like 3. So if I had 3 plus 2i, well, this 2 was a 0? Well, anything times 0 goes away. It'd just be 3. It wouldn't be a complex number anymore. So say b can be 0, big deal. So what's a conjugate? When we simplified fractions that had a radical in the bottom, we used the conjugate. For example, if I had 6 over 2 plus radical 3, how do I get rid of that radical 3 in the bottom? Don't I multiply it times 2 minus radical 3? So when I do to the bottom, I have to do to the top. This is the conjugate. The only thing I switch is the middle sign. Okay? So we've dealt with conjugates before. So if we have a real, if we have a complex number, like with an I in it, as a root, and its conjugate is also always a root. You don't have to do the math to prove it. So if 2 plus 3i is a root, 2 minus 3i also has to be a root. It has to be. I know we started this over, notes-wise, but when we solved this, what were our roots for number 3? X was what? Well, actually, we can do the roots right here, can't we? Without even doing the polynomial? X is 3 for here. X is 3 for here. X is I. And x is negative I. Guess what? This is 0 plus I. This is 0 minus I. They're conjugates. If this one's a 0, this one has to be a 0. We've done this actually before without you knowing it. Right here. This x is a positive radical 2 times I. This x is a negative radical 2 times I. Those are conjugates. Because second, it's 0 plus, 0 minus. If this one is a root, this one has to be a root. So now we're going to take this information we know, and we're going to use it. All right? Write a polynomial function of minimum degree in standard form with real coefficients. We're just going to polynomial at the end. Don't worry, Saturday ain't crazy. Whose zeros include -3, 4, and 2 minus I. So what they're telling us here is one of my zeros is going to be -3. One of my zeros is going to be a 4, my answers. And one is going to be 2 minus I. Oh, but I know another one now. What's the last one? Yes, thank you very much. If 2 minus I is a root, then 2 plus I has to be a root. It has to be. And all we're going to do is we're going to reverse T-bone these to get our polynomial. What is going to be the factor if my answer is x minus 3? Yeah, I just switched the sign, right? What is going to be my factor if the answer is x equals 4? Yeah, we're just flipping that sign, right? This was a minus, this was a plus, we're just flipping it. Now, be careful here, because this whole thing is my answer. This was positive, right? In front of it, it's x minus, and in parentheses, 2 minus. And the last parenthesis, what do you think it's going to be? X. Yeah, because technically, no. This still is technically a positive value here. We're going to subtract 2 plus I. Okay? So the whole key here is organization. And I did this with period 2. And they seem to get it, and it wasn't that bad. And the whole entire key is just be organized when you write it. Because if you do this, it's going to be okay. Donovan. Yesterday, when I was telling you guys a quick way to do this, instead of actually foiling it out and combining the middle term, do you remember that or no? Okay, so I have x squared here, all right? It's going to be, and then I'm going to have two numbers in my quadratic when I FOIL, right? If I had the quadratic first, and I had to find out what it factored to be, shouldn't these two numbers multiply to be the last term and add to be the middle term? So what do I get when I add 3 and the negative 4?
Oh,
Not 3 and negative 4. Negative 1, and this is where the x goes, right? So it's a negative 1x. I don't have to write the 1, do I? And what do 3 and negative 4 multiply to? I mean, so you can do that all the time without FOILing. It's a real easy, quick way. And the quicker you get at it, the better it's going to be. All right? Easy. This is done. Okay, I'm multiplying these all together, right? I multiplied my first two. Here it is. I need to multiply these next two. And the answer to this is eventually going to be multiplied to this first quadratic. You know what? When we do that all nice and neat, everything's going to cancel out and there's not going to be any more i's. And the whole key is to do it in an organized fashion. Right? Let's start. James, x times x.
X squared.
That's x squared. Good. Now, when I multiply my x times my negative, in parentheses 2 plus I, so I have a positive x times a negative. That's going to be negative. And then I'm just going to write x times 2 plus I. If you get better and quicker at this, you'll be able to combine that in one step. But I'm just going to rewrite everything right now for the sake of organization, because it's the first time we're doing it. Okay? So now, I'm going to distribute this one. I'm going to distribute that times x. What am I going to get? Yeah. Negative x, then in parentheses, 2 minus I, right? Because that's a minus sign here. Yeah, because it's a positive x times a negative. That gives us our negative. X times 2 minus I. Don't complicate it. Leave it like it is. Last but not least, I'm taking this parenthesis and multiplying it times this. So I've almost got another foiling I've got to do there. Right? It's a negative times a negative, so it's positive. And it is 2 minus I times 2 plus I. What do you know right now about this thing in the back? Yeah, they're going to cancel out. The middle term's going to cancel out. And there's going to be no I there. And when I distribute my x's in the middle here, you'll see things go away too. So let's clean this up. We have x squared. Okay. I'm going to take this negative x and distribute it in here. So what am I going to get? Negative x times 2, negative 2x. Negative x times I, negative xi. Something like that. All right. And I'm going to do the same thing with this negative x times this 2. So what am I going to get? What am I going to get?
Negative 2x.
Negative 2x. Negative xi?
How many positives?
Positives. Negative plus xi. Right now, I can tell my xi's are going to cancel. We'll say that. So that i's going to be gone. Now my end here. I can, but I'm going to finish it off. Well, yes, I can. I can. 2 times 2. So that's 4. I'm going to write this up here and then write it again down here after I combine it. What is 2 times I? So it's 2i, so plus 2i. Alright? What's 2 times a negative I? Negative 2i. Those are going to cancel. Sweet. We knew that. Oh, yeah, careful. It's a negative I times a positive I. Well, it's first of all, negative times a positive is negative. Then it's an I squared. And you're telling me I squared turns into negative 1. Be careful here, because don't just change to negative 1. It's only the I squared. So we're actually subtracting a negative 1. Okay? Right. And what else cancels in that? We'll just spoiled right here. My negative 2i and my positive 2i cancel. And now we have 4. This turns into plus 1. What is 4 plus 1? What else can I combine in this right here? So this cancels with this. And is there anything else? Right, so I ultimately end up with x squared. This will give me right, minus 4x plus 5. This whole big mess, right here, from here, and I multiply into this whole thing, actually worked out, so there are no i's left. Look at that. That's sweet. But I still need to multiply this times this right here. I know. It's like 3 problems in one. It's like 3 problems in one. This is definitely a part 2 type of question. Okay? There are 3 problems in one. But guess what? When we FOIL this, we're done. Okay? So we had to FOIL the first 2. That was really simple. Okay? X plus 3, x minus 4. Well, it should be, otherwise it's in the wrong math class. We had to FOIL the second part, which was new to you. Okay? Actually, you just learned it, and now I'm just going to multiply them together. So, when I write these things, I'm going to line them up vertically so that the terms match. It's going to be easier to. Yeah, go ahead. What's x squared times x squared? X to the 4. What is x squared times negative 4x? Negative 4x cubed. And Donovan, what is x squared times 5? Plus 5 squared. Good. Now I'm going to distribute that negative x. Don't forget, the middle term has to be distributed as well. So it does. What is negative x times x squared? So it's x cubed, I'm going to put it underneath my x cubed here. I'm going to say negative x cubed. So they're already lined, right? What's negative x times negative 4x? So it's plus 4x squared. Good. Negative x times 5? Negative 5x. And of course, there's no other x yet, so there's nothing to combine that with. Last thing. Yes. This times this, you're absolutely right. It'll be negative 12x squared. I will line that up with my other x squareds. Positive what?
48.
Positive 48x. And what's this last one?
60. Negative 60.
Negative 60. Now, these are all lined up nice and neat. These are all lined up nice and neat. So I can add them. So, I only have my 1x to the 4th. Now, if I have a negative 4x cubed and a negative 1x cubed, negative 5x cubed. So how many x squareds am I going to have?
Oh, you negative 3.
Negative 3x squared. Right, because I have 9 minus 12. What about my x's?
43.
Plus 43x, and then here's my minus 60. This is my polynomial. Let's see what it asks for. A polynomial function, minimum degree, so at the very least, we need to have at least 4 x to the 4th power. How come? Because we have 4 x's to start. We have this x, this x, this x, and this x. So there should be 4, and we have that minimum. Okay, so the minimum in standard form, well, standard form just means you write it with the biggest exponent first, and the next biggest, and the next, and so forth. In standard form, real coefficients, are there any i's in those coefficients? No, good. With the zeros included, which we already have. That's it. All that fancy terminology just means to give the polynomial. There it is. And if you wanted to track that, if you wanted to graph this, how many times does that touch the x-axis? Twice. How come it's not 4 times? I see 4 zeros here. Thank you. I see 4 zeros here, but you're right. It only touches twice because 2 are imaginary. There's an I, there's an I. That means they don't really touch the x-axis for real. They're imaginary. I will touch the x-axis twice. Where? -3 and +4. That was a lot of work to get through. I mean, look at that board. That looks like a mess. Yeah, it's just spoiling. It's spoiled. It's very algebra heavy. There's no triggers or nothing. You just got to be able to distribute and combine. Okay? Problem 5 says, write a polynomial function, minimum degree, standard form, real coefficients, whose zeros include x is 1, x is 1 again, so that, remember, multiplicity of 2. So that's going to have a factor of x minus 1 and another factor of x minus 1. And you do it twice. X equals 1 plus 2i, and x equals 1 minus I. If x equals 1 plus 2i is a root, what else is a root? What else is a root? Well, 1 minus 2i, right. Alright, if x equals 1 minus I is a root, what else is a root? Stop putting x in different ones. You have 1 plus I. So guess what? I see 1, 2, 3, 4, 5, 6. This is what I'm going to do. This is what I'm going to do. That's going to be a lot of work. This is what I'm going to do, though. When our test comes up for this unit, I'm going to let you guys do this one for homework on your own so you can get it right. When the test comes up for this unit, if you do this, because I think there's only 8 problems for homework tonight. If you do this, you can do it on a separate sheet of paper on that sheet right there. Get it to me. If you get it 100% correct, work and all, just don't give me the answer without the work. I will give you 8 more percentage points on the unit test. 8. Which means that bumps it up almost a letter grade. Definitely goes from like a C to a C+, goes from a C+ to a B. That almost brings a C up to a B. Depending on where you fall with your number. If you get a 72, that'll bring it up to an 80. That brings a C to a B. Yeah, that's what I'm talking about. So if you can do this, I'll give that to you. All right? And that's the end of the note. So tomorrow, when you get the homework done, that's fine. If you have this too, I'm going to collect this. The homework we'll just go over. I'll show you the answer. We'll go over it. If you have any questions, I'll do them. But this is the one. Yeah, let's go. You can do it.